Edge Analytics enabled acoustic rain gauge. Hello all. We represent the Smart Weather Station team from the International Center for Free and Open Source Solutions, Trivandrum. In this video, I'll be walking you through my team's work titled Edge Analytics enabled acoustic rain gauge. International Center for Free and Open Source Solutions is an autonomous organization set up by Government of Kerala, India, and having the combined mandate of popularizing free and open source solutions for universal use, consolidating the early force work done in Kerala and networking with different nations, communities and government to collaboratively promote force. ICFORCE is the outcome of a decade of work by free software enthusiasts, advocates, developers and supporters in the states of Kerala and outside. The 2018 Kerala floods were one of the most devastating natural disasters in the state's history, caused by unusually high rainfall during the monsoon seasons. The floods resulted in widespread destructions, displacing millions of people, damaging infrastructure and causing significant loss of life and property. This catastrophe highlighted the urgent need for improved climate monitoring and forecasting systems. Accurate and high-resolution climate monitoring is crucial for early warning systems which can predict extreme weather events and help mitigate their impact. By closely monitoring climatic conditions, we can enhance disaster preparedness, ensure timely evacuation and protect life and property, ultimately building more resilient communities. Rain gauge is an important component of weather stations. Existing rain gauges consist of mechanical parts which require frequent maintenance and human intervention. Mechanical rain gauges often rely on moving parts to do the measurement. The photograph shown here is called the tipping bucket mechanism of a mechanical rain gauge according to the Indian meteorological standards. The moving parts are susceptible to clogging, wear and tear, etc. and require frequent maintenance. It is desirable to have rain gauges which are no moving parts, require minimum maintenance, consume less power and are economically feasible. The sustainable development goals such as climate action, life on land are aligned to the concept of what we are going to develop. In order to achieve these features, we have developed an acoustic rain gauge which uses rainfall sound data from an enclosure as input data and IoT devices and sensors as hardware. We have used a USB microphone connected to Raspberry Pi 4 board to do the data acquisition model inference. Here, our Raspberry Pi board receives both the sound signals as well as reading from mechanical rain gauges, which are stored into flat files. The whole system is powered by a battery, which is rechargeable by solar power. Deep learning models are used for doing the function approximation of sound data to actual rainfall data obtained from the mechanical rain gauges. The figure here shows a spectrogram of 10-second audio clip during rainfall. As we can see, each vertical line represents sound corresponding to the impact of raindrops to the enclosure. The frequency and intensity of vertical lines changes as per the rainfall intensity. Likewise, the table here shows the reading from mechanical rain gauge in 3-minute interval. Clearly, we have a pattern here that can be learned using deep neural network. In the spirit of reproducible research, both the code and data are made public via GitLab and Kaggle platform. This figure shows a scatter plot model for prediction as well as actual values. We can see an almost linear relationship between the actual values and predicted values. The table here shows the model performance on various features such as short-time Fourier transform, chroma and MFCC. As we can see here, the LSTM model on STFT features gives the best performance on test data. Our LSTM model shows a mean absolute percentage error of 12% on test data. We have calculated the power consumption of POC using Kately source meter and it is found out to be 3.3 watts. The live inference data is sent to an InfluxDB database using API call. An open source visualization tool called Grafana is used to display the live data. Coming to the conclusion, we have developed a non-mechanical acoustic rain gauge. The proposed DNN LSTM model has a mean absolute percentage error of 12%. The average power consumption of the POC is found to be 3.3 watts. Future scope involves making the product most cost effective, easily replicable and low power consumption. We would like to extend our sincere thanks to IEEE for this invaluable opportunity to present our work on the Edge Analytics enabled acoustic rain gauge. This platform has provided us with a crucial avenue to share our innovations in climate monitoring and sustainable technology solutions. And also we thank IEEE for promoting and fostering innovations in the field of engineering and technology.